So in this particular machine, there was four people: a president, a vice president, a secretary, and treasurer, and the majority rules. So some of them are simple. So one means yes, zero means no. So here, all four said yes, so the vote will pass, yes, for sure. And the majority wins. For example, these three said yes, so of course it's going to pass. These three said yes, so it's going to pass. But in the event of a tie like this, 1-1 versus 0-0, the president, right here, P, breaks the tie, so yes, it will pass because he says yes. Here, three people said yes, 1-1 and 1, so of course it's going to pass. Put a 1 there. And here there's a tie. President says yes, so it's going to pass. Here, the president and this guy said yes, so it's going to pass. Here, only the president said yes, so it's not going to pass. Here, they gang up against the president, yes, yes, and yes, and the president says no, but it passes because majority wins. And the rest of these are not going to pass because there's just too many zeros. In this one, there's a tie, but the president said no, so it's still 0, 0. And of course, this one's 0 because they all said no, so of course it's not going to pass. So this is the vote D decision if it passes or not. And then if you're going to create a unsimplified logic expression, we just write down a minterm for every single one. For example, this one right here is not P, V, S, and T. That's this one. V, S, and T are on. The P is off right here. So we write that one. Every time you see a 1 on the output, remember this is the output and these are the inputs. We got 4 inputs and 1 output. And every time we see a 1 on the output, we're going to write down a minterm for it. So this one right here is going to be P, V, S, and these are off, and the T is on. See, this one's on, that one's off, but these two are off, so we do this. And this one is going to be P, V, S, and T right here. Yeah, that's right. And then this one is P, V, S, T, but only this one's off. So I'm going to write it out here because I'm running out of room here. And then this one is both the first two are on, and the second two are off. And this one they're all on except the third one, so P, V, S, T, and this one's off. And this one they're all on except the last one, P, V, S, T, and that last one's off. And here they're all on, so P, V, S, and T. And then we rewrite them as if, so if I tell you to give me the full logic expression, these are called minterms, M-I-N terms. So those are called minterms. We want to write the full unsimplified logic expression, so let's do it. So we'll say the decision is equal to PVST, so this first one, or PVST with the two lines, that was that one, then or PVST here and here. That's under the V, by the way, right here. Then this one, PVST, with only the V. And then or, and I'm running out of room, so I'm going to continue here. Where was I? There we go. PVST with these two off, then only the S off. PVST with only the S off. And this one, only the T off. PVST or PVST. There we go. So if we were to write this down in its entirety, I should have just done it here, and I would need a smaller brush probably. I should have done it right here. You're going to do a Boolean algebra to simplify this. So how do you simplify it? Well, let me see if I can start and help you guys out a little bit. So let me see if I can write this a little quicker without going over this over and over again. My V's are starting to look like U's. There we go. I fit it all in one row. Started to get a little small there at the end, but I did. Now, how do we simplify this? Boy, where do you even start? How do you even start? Well, you need stuff that looks similar. So you could start to like try to use like distributive properties. For example, if you look where the p's are in common, so we have a p, a p, a p, a p, a p, p. So these, all of this has a p in common. This one has a not p. So you could start just put p and then multiply it by and then distribute it vst or vst or vst or vst or vst or vst or vst. So you could do that, and that did simplify it a little bit there. I mean, not really. We didn't really cancel anything out. But we did get this. Then we can look to see if there's anything the same. Nope, nope, nope. These all look different, don't they? They all look different. Well, what do we have in common with any of them? Let's see. The VS not here. The T. We can start to break this down like right here. Look at these two, just these two alone right here. If I take the VS out and I distribute this, so if I'm just breaking this down, so it's distributed like this. A not T and a T. Sorry, a not T or a T. Well, that's always going to be a 1. So really this breaks down to just VS. So we can cancel that one out right there. So finally we're starting to simplify something. So this is a VS. And then you can go V not ST. And then you have to rewrite all this again. ST not V or VS. Anytime you have a like an X or a not X right here, if you have this, then what happens is one of these will always be a 1. Remember, whether X is 1 or a 0, one of these will always be a 1. And on an OR gate, because that's what the plus sign means, on an OR gate, if one of them is a 1, and one of them always will be, right? So if X is 0, then that's a 1. If this is a 1, that's a 0. So one of these will always be a 1. That means the output's always a 1, okay? Now, if it's an X like this, then that's always going to be a 0, and then you just wipe the whole thing out. The whole thing becomes a 0. So that's because one of these will always be a 0, correct? Just like one of these will always be a 1. But one of them will always be a 0. And these are AND gated together. Remember, they're multiplied. So this will always be a 0 because one of them will always be a 0. So the whole thing will be a 0. Because an AND gate, both of them have to be on to be on. So just think of it like that. So VST, where was I? 2 T's. I'm missing the T here. I'm doing that one there. VST or VST. And then we'll close the parenthesis here and put a P or. So we started already simplifying, and you could do that again. Look around, I got a not T VS. I think you can simplify something here because you got 3 not V's in a row, and you can pull the not V out and then bring ST, ST, and you'll see you have 2 STs that can cancel out. So little by little, I just want to see that you do your best to simplify this, okay? I want you to show your work and turn this into me. Because if you look, your assignment says today to... is this not... So, well, hold on 1 second, folks. Sure, tell mom, go with mommy for 3 minutes and I'll take you to grandpa's house. Go sit down in the living room. So anyway, where was I? Oh yeah. So it says turn to the following. You're simplified. That means do Boolean algebra to it. Logic expression. Do the best you can. It's probably not going to be perfect, but do the best you can. Let's see how good you are. I want to see your work right here. So just like I'm showing you my work, I want to see your work. Do the best you can. Look at those rules and just do the best you can. Second thing I want you to turn in is go to this website and put in the equation. Now squiggly lines means not. Plus signs are ors. We already know what those mean. And the multiplication means and. Okay. So what is this right here? See this right here? Your answer. I don't know. Check your answer. So this Boolean expression, your answer. I don't even know. Here. So what I would do is this. I think you would put the equation right here. Let me try something. In fact, I'm going to do one just to experiment. So watch this. I want you guys to realize this. Let's say AB. Actually, let's use PV and S's for now, since that's what we're using. P, V, S, or P, V, not S. This will simplify to this right here. Okay? That should be your answer. The reason being is if P, V are on and S is on, then the machine will turn on. Okay? Or, that's what the plus means, or, if PV are on and S is off, the machine will turn on. But look at this. If PV are on and PV are on, and S is on or S is off, it doesn't matter. So think about it. It wouldn't really matter. If S is on or S is off, as long as these are on, then that's what matters. Okay, because we have, it's just PV and S is on, or PV and S is off. So because it doesn't matter, notice that the S is on or off, it has no effect. Really, what really matters is whether PV is on. So that's why this simplifies to this. So let's see if that works. Let's stick this in the equation and see if it simplifies. I'm not sure where I'm supposed to put it, here or here. It's kind of weird. Use the calculator to reduce your Boolean algebra to check your own answers. I don't even know what that means. But let's just put it here then. I don't know. I'm going to put it here. So PV S. Oh, but you can't put it like that. Yeah, I think you have to put the P and V and S. I'm going to put a space, or P and V and not S. So where's that little squiggly at? It is, oh, there it is. It's way top left, right next to the 1. Not S. So I put P and V and not S. Check answer. Your answer. Let's see. Copy. Paste. Use a squiggly to represent. You know what? I wonder if I have to put these in parentheses. Let's see. Maybe that's what it was. Let's see. Oh, and no spaces, huh? Maybe that's it. P and V and S, or P and V and not S. And do I have to like copy it and say that's my best answer? It does not like it. Boolean. The following examples are how you're supposed to write it. Am I supposed to put spaces or something then? Maybe that's why. These things are really picky. Let's see what happens if this works. Uh-huh. Okay, check my entities again. What am I doing wrong? Squiggly line. Okay, use this as represent. Do not omit the operator or the AND operator. This will be returned as an error. This is okay. See how it says this is okay, but this will return as an error. So, somebody's yelling at me in the chat. You can definitely use a different calculator if you can find one. Logic Friday is way better, I'll tell you that. But it won't. It's not web based. You have to like download it, install it. I'm not. That's the one I always use in class. That's why I'm kind of new at this one. I've used this one once when I had to, but I had to figure it out, and I'm not sure where I'm going wrong here. Let's see here. This is okay. Oh, so it just doesn't. No, you don't put spaces in. It says that that is okay. Copy. Paste. Once again, it does not like it. What is there? Because there's a space here. PVS. So it says that's okay. That's okay. I don't know why that's okay. Do I have a space here? No. No. Let's try something more simpler. Let's just try this. Let's say PS or P. Oh yeah, and you have to put the not and, right? And P and not S. Copy, paste. Oh, but these have to be in parentheses, of course. Because it might think that I'm ORing the S and the P in the middle. It doesn't know what I'm ORing, you know? Because the plus sign is between the S and the P, but really I meant to OR these two pieces together. So check. Copy, paste. What am I supposed to do? Check my entities. Does anybody see what I'm doing wrong? I don't know what I'm doing wrong. Oh, can I only use the A's and B's? I bet you that's what it is. You can use A, B, C, D, I bet. Oh yeah, here, look, right here it even says variables E, I, N, O, Q, and S are not allowed. Look at that. Gosh, how did I not read that rule? Okay, so let's just use it. A, B. So here we go. A and B and C, or A and B and not C. There we go. So same thing, but now, so I have the A and the B, and I have the A and the B, but here it's a not C and a C, so this should just be AB. There we go. It's just AB. So you don't have to put your answer here. You could just put the whole equation here. So instead of PVST, just put A, B, and C's instead, because S is not allowed in this dumb calculator. But if you find a different one, do use it. So this is the same thing. And it does show you what the truth table would look like, by the way, so you can match it up to your truth table. Just remember that A, B, C, and D are really P, V, S, and T. So A is the president in this one. So that's how you got to do it. That's where I was going wrong the whole time. I was just using a letter that it did not like to use. So just use A, B, C, and D. And make sure you put the little multiplication signs in between each letter. You have to do it that way. You can't do it like the lazy way we usually do. For those using Logic Friday, if you want to download it, do I have Logic Friday? No. Watch this. So you got to go to Logic Friday. If you have a computer, even I think a MacBook, I'm not 100% sure, but go here and then download Logic Friday. It's a very small program. Would you like to install? No, I just want to download it. Save. I'm just installing it. It's real quick. It's installed already. I didn't even have it, but here it is. This one's really cool. Let me show you why. You could technically put the truth table. Watch this. So you can say new, and you can say truth table. Or you can put the logic expression. The truth table is easier. So how many inputs do we have for this machine? We have 4, right? So we can do 3, 2, whatever we want. We have 4. How many outputs do we have? We only have 1, right? And our output, we'll call it D for decision. And, I can't use it because it's already used for an input. So P, V, S, and T. And what's our output? We'll call it D for the decision, but okay. Now look at this. Here we go. It already does the whole truth table for us. 0, 1, 0, 1, 0, 1, 0, 1, 2 zeros, 2 ones, 2 zeros, 2 ones, 4 zeros, 4 ones, 8 zeros, 8 ones. It already does it. And here's the decision. Click on it to turn it to a 1. Double click on it to turn it to a 1. If you click on it again, it turns to an X. It means you don't care whether it's on or off. We'll talk about those at a different time later on. So this one is definitely on. This one's on. This one's on. This one is 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 off. This one is on. And that's it. The rest are off. So we're doing that, right? Now I think you push enter, but you could just push submit. So you either push enter or submit. When you do that, it gives you the whole truth table, the whole logic expression, unsimplified, of course. So not P, that little comma after the P means not P, VST, or P, not V, not ST, so on, the whole thing, right? You want to simplify that equation? You would just go to equation, and no, truth table, no. You go to operation. You go to operation, minimize. Operation, minimize. It sounds like a military operation. We're doing operation, minimize. And I go minimize. And do you want to do it fast or exact? I don't know. It doesn't really matter. This is a simple problem anyway. And that's the answer, but I'm not going to show it to you guys. Anyway, so that's all I have for you, folks.